Alright, hi, I'm Tom and I talk about code. Welcome to another Rust programming live stream where today I'm going to be working on the web user interface for my virtual machine. We're going to be doing a few random cleanup tasks. Again, not the longest stream today because I do have a singing lesson to get to at some point, but we're going to do a few nice little tidy ups. It's looking a bit different to the last time anyone saw it, which is really exciting. So let me jump over and show you what I've done. A lot of this happened yesterday. So this is, the simple VM playground. Might be good to rename this at some point, but it's looking more like a thing I could put on my website and not be embarrassed by, which is cool. I don't love that this doesn't align, but that's okay, we'll live with that. So you have a program, you type it into the program view, you hit build. Actually, let's go back. Let's put this at a sensible offset and let's give ourselves some actual memory. You hit build and you get this program view where it shows you the offset in memory, or the like program offset, right? What address is this instruction at? So as you step through the program, when it says PC4, not only can I check with this line number, but it also highlights the line in red. So you can see what's going on as you step through. This is really cool. This is really important. So there's a few things that are a bit rough. For example, we hit this system call. This is the halt system call. And we can just keep stepping and the machine will crash. So one thing I really want to do is map a better handler into this into the system call so that it can actually stop us doing things so we don't keep doing that. The other thing is we can hit run and it'll do that automatically. It'll step through, and it's hard to see that unless we run a more meaningful binary. So let's do that. Let's grab our test program from the other day, cargo bin, we're going to disassemble it, and then we're going to copy it. Nice, so if we go back to edit, we need to make the memory size a little bit bigger. These have sensible defaults. If I get rid of this, it actually defaults to 0 and 8000, which is fine. Cool, so now we can step through, right? Blah, 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 blah. And if we hit run, it'll run through to the end and we can see the answer in the A register, which I can't select for some reason, but that's okay. Just look towards the upper left-hand side of the rightmost column, right under the word VM control. Cool, so if I go back to edit, one thing I can do is put a different, I can massively, okay, that's not quite right. Let me reload the page. For some reason, this timing calculation is a bit off, but except I have to go back and do this more meaningful program. Now if I hit run, we can actually massively downclock the CPU so we can see it step through each instruction at a time. The stack frame view is a little bit janky, there's some things that are a little bit off here, but overall this is feeling like a much better way to work with this machine. We can actually see what's going on, we can see the jumps, we can see the stack frames build up, we can just set that running, right? And it's extremely satisfying to see all the little things ticking away in the background, all the registers changing, all our recursive calls piling up, and then at some point we're gonna pop all these back. We're gonna walk back down this stack of base pointers to our init function and call this system handler, which is really exciting. I think we're almost done. We should be walking back up soon. I'm just enjoying it anyway. Oh no, hold on. 5, 4. We're getting there. Look at the B register. 3. It's happening. 2. 1. Now we're going to walk back up, and these are all going to get consumed. There we go. And so we should see the A register, has our answer in it as we recursively just return the A register. And then we're done. Excellent. That's really satisfying. That's really exciting. I hope that was as exciting to everyone else. There's something about seeing your machine just, tick away. So also, for comparison, I guess, this is what it looked like before, and this is what it looks like now, so it's a little bit nicer. I should probably, at the moment, let's have a look at my code. It's really not that good, right? This is all just, there's one script tag, and it's a bunch of weird little functions that do stuff in a very simplistic way. I should probably rewrite it as a view app, and especially one thing I would love to do is to have, oh, I can select now, that's cool. These registers, have them be actual inputs that you could modify. So, you can see them change, like it's got that reactive, as it changes in the machine, it changes there, but then if you edit it, it would change it would set the field in the machine. That would be really cool. That would be useful for like running and pausing and playing around with stuff. That would make my workflow a lot easier. But we're not there yet. We're not there yet. I don't know what I'd do for flags. That maybe wouldn't be wouldn't be editable. But yeah, that's really fun. That's really exciting. So today, the first thing I want to do is right now, when you make these system calls, the system handlers have to be written in Rust. I want to see if I can make a system for binding in JavaScript handlers. That would be really, really nice. That would be way nicer than what we're doing right now. And then the next thing from there, according to my little list, is to make this bit of UI actually do something. So conditionally attach a screen, which starts at some offset, like a 40 pixel by 40 pixel screen or something like that. Maybe I should let you set the size as well, but for now we'll start with a fixed size. And also have what I'm calling a terminal output, which is going to be like a serial in-out. It's going to be very specific how it works, but and probably quite limited, but it'll let you do text input and output. This device will be a bit harder to write than the screen, I think, funnily enough, or it'll be harder to make it actually do stuff. But both of these are things that will be pretty approachable to do. I don't know if we'll get them both done today, especially because I've been just yapping for 6 minutes, but we're gonna make a start and see about these system handlers. So let's jump into where we're doing our WASM, and where do we set up the machine? We define handlers here. Now handlers currently take a function, right? And I've had a thought about this because I've been doing a bit of work with my parser combinators. And the way parser combinators work is, the way I've been working with parser combinators is to define a trait and then implement that trait for a whole bunch of functions. Now, if I, instead of my machine handler, define handler, takes a signal function. Signal function is a function. This isn't as useful. So let me let me define a trait called signal handler, and it's going to have one method called run, or maybe a method called handle, right? That maybe makes more sense. It's going to take a mutable reference to a machine, and it's going to take one argument, which is just one number, and it gives us back a result with nothing. Excellent. Now we can say impl f for f. We can implement it for f, where f is a function trait from with this size, with this shape rather, and this should work. I'm pretty sure this works. This needs to be a function. Oh, and it needs to now take itself as well. Maybe a mutable reference to itself. Which one makes more sense? Maybe just a self. Maybe just a self. I don't know if it mutates the machine. It doesn't. Yeah, these can't contain state. Any state contained here needs to be wrapped up in the machine. The signal handler itself is not stateful. So let's go self, a mutable reference to a machine, which I can't spell, and an arg. What am I? That one. You can tell it's cold because I'm struggling to type. And we just call the function that we're implementing this on. Excellent. So signal function no longer exists. We now have a signal handler. But the cool thing is, if we make this a signal handler, anywhere we previously used a function, that should be accepted as a signal handler, I believe. I believe this will work. We're going to find out pretty soon. So system. Sig. Okay, expected one of 7 possible tokens because, again, I didn't do things properly. Signal handler. It's really hard. It's really, really hard typing when it's called. Now, there's a few things that have gone wrong here. Type of signal handler cannot be known at compile time. That's because we need to put this in a box. Except the dyne goes here. Excellent. Okay. Doesn't have a size known at compile time because this now has to impulse signal handler. What else is going on here? Box. Handlers insert box. New. This is nice. This is one of those places where you can hide the fact that it has to be a box under the hood by using it by passing an arg. The type impulse signal handler was developed in its lifetime. So I don't think this is right. I don't think this is right. I really don't think that's right. Can it borrow self as mutable because it's borrowed as immutable? Immutable borrows here. Mutable borrows. Immutable borrow. Okay, so we get a reference to this function. I don't know why this has changed. I really actually don't know why this has changed. Can I dereference this? Will that fix it? Oh, wait. Result string, because I want to dereference here. Can I do that? Okay, we've got a borrow checker knot. We've tied ourselves in a knot. Bobius2, welcome. I really like this Bobius2 guy. He's a lot cooler than Bobius1. How are we going today? I was going well, and now I'm looking at the borrow checker, and now I'm not doing as well. Okay, so immutable borrow happens here. Mutable borrow occurs here. Is this because there's a dependency between this and this, right? Because signal function, the what's the word I'm saying? The lifetime of the reference of the signal function, which isn't a function anymore. Let's just call this handler, because otherwise it's going to get confusing. Sig value. Handler.handle is one of my favorite. This is a pattern that pops up often in programming, where you have a handler.handle. You got to handle the thing you're handling. Okay, so there's a problem, and the problem might just be the order I'm doing things in, because self. So this is an immutable borrow, right? The handler is tied to, because we get a reference from this. So we can't clone this, can we? We can't clone this. That would be silly. No, same issue. Mutable borrow occurs here. We mutably borrow self. We immutably, yeah. That's really annoying. Let's see if someone else has this. Aha. I think other people have this exact question, I suspect. Now, last time, I did a really bad job of actually reading the question. So I'm going to try and do better than I did last stream. Let's just get rid of this garbage taking up my screen space, which becomes very apparent when I start to zoom in. I have a function now, 2 references, one mut and one not mut. Values are f. Map insert, map get. I think this is the same. No, this is a different question. It's kind of the same question. It's the fact that A holds on to this. Does it? A stays in scope till the end of this block. A holds on to like a reference of this map as I understand it, right? Because immutable, yeah. So while A is still in scope, B cannot mutably borrow from map. You will need to change the type of hash map. Ah. Get will borrow for the hash map KV. Okay. So this isn't the same question, but it's the same concept, I think. I don't know if this will actually fix it. Maybe it will. Maybe it will. Because once you call borrow on a RefCell, maybe that maybe the compiler's smart enough to know that this isn't. And I guess Rust got smarter at some point because it can work out that likely it can work out that A isn't used again, right? The fact that the scope, it can see that B doesn't depend on A, so it's happy to untangle this. I've got the situation where, okay, let's see if we can draw this out. So let's get a new color. We have a map. We have our map. Well, we have our machine. Let's call it VM. And inside of our VM, there is a map of handlers, which has, it goes from I don't know, an int, let's say, I can't remember the exact type, and it gives us back a, let's just call it handler. So when we're in something, we say self dot handlers dot get X is a ref. It's a ref to a handler. If you can read my horrible writing. So X is a reference to a handler, right? So as long as this reference exists, I think we essentially hold a reference, like we've essentially borrowed handlers, right? The lifetime of X and handlers are permanently tied together. Now, we could sever this link if we could make a clone or some kind of copy of X, but I don't think we can do that. I don't think we can clone a function, right? Maybe we can though, right? Because the function... because previously this was just a function, right? And like you can copy the address of a function. It doesn't need to be tied to the lifetime of the map. But now we're saying this is a type that maybe. So what if I say clone? What if I say copy? Does this work? But what if I say handler dot copy? Right? Found in box. Wait, whoa. Did you guys see that type? That wasn't a box T. That was a ref to a box T. So maybe this is, can I let me get my Rust docs up. Using the local docs. Can I go from a, can I deref? No, that's not right. That's something else. What have we got? Where's the first instance of this? This is all... I feel like I just wanna say let... What happens if I do this? Move occurs because handler doesn't implement the copy trait. Well, okay, let's try another thing then. Let's try .clone. This still probably doesn't work. Yeah, because... what's self here? Self is a mutable ref. Oh, this is way harder than I thought. This is so much worse than I thought. So we can't copy this. We can't copy this. Copy? Clone. No, wait, yeah, we don't use it like this. We don't use it like this. Oops. What am I doing? Handler does not implement the copy. Yeah, sorry. Okay, there we go. So box. Ah, pain and suffering. How can we unpick this dependency? How can we unpick this? Okay, what are we actually doing? What do we actually need? So this was a dead end. Forget this. This is all correct. This is why this is happening. So what are the inputs? We have a handler. The handler has to take in a VM, but the VM owns the set of handlers that the handler lives in. This is the problem. This double link is the problem. So how can we restructure this to avoid this situation? How can we restructure this to avoid this situation? So what other possible structures are there, right? We could have, let's say X. This is the same issue, right? Because you get this double link. How else can I set this up? Is there another way? Have I delved into the territory of the impossible? Can I just not have it? Like, surely other people have encountered this before. Surely I'm not the first person to bash my head against needing... Does RefCell actually somehow solve this? Let's... Right, because essentially if we're able to do something here, right? If we're able to do something here that tells the compiler that these things are no longer linked, basically, right? That we're able to somehow make a clone or a copy and say that this thing no longer depends on this part. Can we do that? Is that what is that something a RefCell would allow us to do? Shareable mutable containers. Cell. Well, I mean, what's cell? Memory allow unsafe cell. Cell enables mutation inside an immutable struct. This still isn't right, but it might allow the kind of... I feel like this kind of is the thing though, right? Where we're basically stepping outside the borrow checker. So let's see. Let's see if wrapping the handler in a RefCell is gonna fix it. Otherwise, it might actually need to be the VM that gets wrapped up in a RefCell. Let's try it, okay? This is one of the many things I've learned about Rust. When you have a problem, RefCell might just be the solution. Okay, so we're gonna dive in. Let's go RefCell. It needs to be wrapped in a box anyway, so that, I think, does it? Yeah, sure. RefCell box. We also need to use std cell RefCell. Wonderful. Okay. So now we're going to get some new errors. What else have we got? Unsatisfied trait bound. Let's just get rid of this. Method cannot be called on RefCell. Okay, so now we just said borrow.handle. What do we get now? Same thing, same thing. A temporary with access to the immutable borrower is created here. The immutable borrower might be useful here. It might be used here. Might be used here. When the temporary is dropped and runs... Ah, it has to keep it around because of the potential for a destructor. So... and make x be the expression at the end of the block. Oh, that's stupidly clever. Oops. This is so stupid. But we have to. It can't be the thing at the end of the block. This satiates the borrow checker, right? If we maybe temporary drop. No, that still wasn't enough. So immutable borrow occurs here. So actually, is it the map itself that should be wrapped up in a RefCell? Untangled Co says it seems clever. Seems clever to them. It doesn't work anyway, right? It doesn't work anyway. Maybe I've actually put the RefCell in the wrong place. Maybe the thing that needs to be in a RefCell is the whole map. Because this is where the... that was convenient. This is where the link actually is, right? This is where the link actually is. So, new signal default. Does RefCell have a default? Probably not, right? This is gonna... I'm gonna need an explicit default instance. Am I? RefCell apparently has a default. That's good. This is my favorite comment. I've got to bring this up on stream. This kind of thing's beyond you. You'd have to do the same thing I'm doing and just try stuff out. This is my entire approach to programming. You just try stuff out. But in this case, I do actually feel like I'm getting a grasp on what's happening, which is cool. I feel like I'm getting a better understanding of Rust because like these errors look a lot more correct. Borrow mute. What else do we have? Get. Now we need to borrow, and then we get borrow, and then we get, I think. Expected a box. We got a RefCell. Ah, for fuck's sake. Borrow later used here. Okay, so we've got a different error. We've got a different error, but we're honing in. I feel like this is progress. I feel like this is progress. Okay. I feel like we're honing in towards a solution here. Okay, hold on. Wait. Whoa. Temporary values freed here. So what we need to do is let handlers equal self.signal and then handler is handlers.get, right? This is what it's complaining about. And then immutable borrow happens here because it's the same thing. RefCell doesn't solve. There's a type that solves this problem. There is. There definitely is. So what I've come up with, right? What I'm trying to do now, for anyone playing along at home who thinks this is, oh no, I'm out of space. I've run out of room on my page. And I've done this silly thing where I've definitely not given myself. I normally have a fixed background and then transparent layers, and today I have not done transparent layers. So here we go. Okay, so what's happening, right? We have our virtual machine. So we have, this contains a set of handlers. This contains a handler. But here we implicitly, the scope of this implicitly is tied to a ref to self. And so then this is implicitly tied to a ref to self. I almost drew a treble clef then. But this handler also depends on a mutable ref self. And these two things are in conflict. It can't be done. So what I'm trying to do with my RefCell, and this is probably the wrong approach, is to say, hey, here's a layer of indirection. We're just going to call these HS between this and the handler. Because I want to break, like, this outer box, ref self, but this inner box, I wanna deflect the borrow checker so that I can get this thing from, realistically, it's actually, you know, inside the borrow checker rather than, whoops, no path drawing, please. It actually comes from somewhere else. That's the wrong button. This one. It actually comes from this, like, deflected thing. So then this can depend on a mutable reference to self with no dramas, right? I want this kind of shield. I want this bubble around it. There's a type that solves this. It's a matter of figuring out which one and how to use it. Any Rust experts, if anyone knows any Rust experts out there, you know, send out the word. There's an Australian programmer in need. All right, and I'm racing against the clock because I have a singing lesson today, so I got to be careful. Got to not get too caught up on this. All right. We can do this. What are our types? What are the Rust? What are these called? They're ref. There's this set of types. RefCell. So it's not RC, right? It's not RC because RC would not put us in this bubble. I want the type that. I want a type that allows us to. I just don't know if this works, right? Because it's a map, we can't just clone it or copy it or something. We can't just clone it or copy it? Is that a stupid option? Is that something we can do? Oh, thank you very much for this link. Wrapper types. That's the word I wanted. Wrapper types. All right, let's have a book club. Previous post, RW lock patterns important for accessing data. Yes, it occurred to me there are many such abstractions in Rust with their unique guarantees, wrapper types, ownership borrowing, blah, 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 blah. Okay, a box T is an owned pointer or a box. It can hand out borrowed references to the data. It is the only owner of the data. So in this situation, a box here, VM would still be the only owner. We could only hand out a borrow. That makes sense. If we move the box, X no longer becomes usable. That's fine. A box can be moved out of a function. Yes. When a box goes out of scope, destructors are run. This is the other thing. When I had the error about the destructor, is there a way I can assert on the trait that... Okay, I've just had another thought. But let's shelve that one in the back of my brain for now. Is there a way I can run... a way I can assert that my trait does not have a destructor, right? Can I guarantee that it won't do anything when it goes out of scope? That would also be interesting. Copy. Move functions are not social to stop T. They are a feature of all types which are not copy. Copy type, data, logic encompasses. See, the reason I'm even running into this is because the thing in the map previously was copyable and now it's not. So what if I say the thing in the box has to be copyable? No. New copy, new trait. Can I do this? Can I say it has to be copy? For F, where this is this plus copy. And maybe I can't satisfy this trait bound, but let's find out. Signal handler cannot be made into an object. It needs to allow... Cannot be, because it requires sized. Signal handler cannot be made into an object. Oh shit, sorry. Thank you. This is why it's important. This is why I need people, oh god, I did all that reading. You couldn't even follow me reading. I was just muttering to myself. That's beautiful. Okay, so can I make this, can I say that the thing has to be copyable? So there's another thing that I can try instead of this, where I say that I make a new type that, I make a type that, what was it saying? Oh, Untangled Code, you had the article open too, excellent. You were following along. So if I try and put copy here, I get what is it? This is one of the things, right? And I have this problem when I do C++ as well, where I keep seeing these new words and I'm like, how many concepts are there here? How many things do I need to know? What is a non-auto trait? What the hell is this? Additional non-auto trait. A new trait with all of these as super traits. So we could make a trait plus copy, but we're gonna have the same thing. So Rust cannot put sized in box. A new type wrapper. But then this is gonna have the same problem. Okay. I'm gonna go back to book club for a second, just in case there's something more interesting. I mean, I could always go into unsafe. I could always go into unsafe. RC, runtime cost, reference counted, multiple owning pointers, shared reference count each time it's cloned. Like, this would allow multiple immutable copies, but we can't get a mutable copy. So it's definitely not RC. Cell types provide interior mutability, which might be the kind of pattern we want. Like, maybe actually the whole VM needs to be wrapped in a type that allows interior mutability. And to manipulate, even if the type cannot be obtained in a mutable form. This sounds like what I want, right? This sounds like what I want, but maybe backwards. This sounds like we can get a mutable reference from an RC or a reference. Yeah? We can get something mutable where we normally wouldn't be allowed to. This is like... Well, this is exactly what I want. Because we have something... We have a ref. We want both a ref and a mutable ref to be in scope at the same time. It's not a one-to-one equivalence, but it's like the same concept, surely. Cell is a type for zero cross interior mutability only for copy types. So I'm having issues wrangling my... I would like the type to not have to be copy. I feel like that will just create another problem. But if I could work out the right incantations for that, that would also be good. No worry of leaking any data behind. Okay, let's just, okay. Violate your invariance using wrapper, be careful when you use it. Field is wrapped in cell. May not stay the same between when you read it and when you want to use it. That's interesting. Yeah, so x here would be 4. Same runtime cost as the following, but it has the added benefit of compiling successfully. No aliasing and mutability restriction. Mutating primitives. This is almost what I want, right? But I need to not just be able to set it, I need to be able to obtain it. And I don't know if I can do that. Insurance can't be invalidated by mutation of the outer struct. You can only copy out and copy back in. Yeah, so you can't reference the interiors. And that's not quite what we want. I don't... This isn't right? But if in my chart we had this was the reference to self and this was the mutable bit, it would work. Like we wanted to mutate the handlers, that would work. But I don't think this pattern quite works when the mutable thing is the owning structure. I feel like that's probably also incorrect in some ways, but providing this really isn't restricted to copy type. So this sounds better. Borrow mut functions. So ref count is restored, smart points got scope. I feel like I need if could actually never any other borrows and new borrows active. So this actually still isn't what we want, because we're going to, like, if we imagine doing this, imagine we're upper level, right? Imagine we have we've got some function which takes, let's say it takes ownership of a VM, right? So we take a machine. Let's say we take a machine. Oh my god, my writing is really, really bad. This wouldn't work because we'd still need to say VM dot, well, let's say h is VM dot borrow dot 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 dot. We'd have to borrow the VM to get a handler, and then we'd want to say h dot handle VM dot borrow mut, right? And so this is not allowed. Can't get while h in scope. This is illegal. This is illegal. So this still doesn't work. Have I just walked into cursed like impossible Rust territory? Do I have to use unsafe to do this? It feels so stupid. It feels so stupid. Don't types and cross codes and other things. The problem is the thing that I'm modifying, right? The problem is the thing that I'm modifying. Unless, well, okay, actually, I think I see the answer. I think I see the answer, and this is stupid. This is really stupid. Okay? Okay. Okay, so what if we have, let's call our type CTX, and let's say our CTX has a machine and it has handlers. Now if we have a mutable reference to a context, we can we can get immutable reference to machines, and then maybe we can also use, like, I guess maybe a RefCell, maybe another type, something that allows us to have a layer of indirection. I think that works, because if we just tried to borrow this as well, let's try restructuring our whole machine just to make this work. Okay. So, God, I hate this. God, I really hate this. Let's call it derived default. Let's call this machine, and let's call this maybe CPU, right? Because that's probably better. God, this is actually going to get really messy. So this is a hash map between these things. You wait to that. Okay, memory. Let's just call this VM for now. We map things in maybe. Yeah, so this now takes a VM instead of a whole machine. I think this is the way we have to do it. This separates out. There's a name for how borrowing a field destructively borrows a thing. Yeah. So I forgot to switch scene again. Every time. The name for how borrowing a field. Yeah. So I think having a struct that's kind of upper layer is going to be the only solution here. So making a new machine struct with like this inner thing and this outer thing that has the handlers. I think this is what we have to do. So VM, this has a default, that's fine. Self.vm.memory.map, it's going to be really annoying. VM.registers, VM.flags, VM.halt, VM.memory.zeroAll, self.vm. Let's just record a macro to do this real quick. .vm. So we're going to go norm. Whoops. Wrong macro. Yeah, there we go. .vm. Self.vm. Oh no, but this is then self.setFlag. So we need to be careful. Methods are still going to operate on the... Are they? Or are they going to operate on the lower thing? This is hard now because the handler wants to be able to call certain things like setFlag, like potentially reset. Okay, let's undo everything we just did. VM machine. So this is now impl VM, right? And we're going to need a new impl block, which is going to be impl machine. Machine is going to have define handler pulled out, but I think everything else is going to be the same. Let's make this. Do we make it pub? Maybe. And then we kind of have this public API that is going to have to depend on. Oh gosh. Right? Does this make sense? Can we see what we're doing here? We're doing probably the stupidest possible thing. Self.vm.state self.vm.get register r self.vm.set register r. Just this horrible wrapper type. The stack stuff we don't need. The flag stuff I think we do need. Step, and step is it. Okay, cool. So okay. This is really dumb. We're gonna see if it works. We're gonna see if it works. Okay. This is good. So, define handler. This, we can get rid of this borrow mark. Now, I'm gonna rewrite it such that it still breaks. Okay, I probably have about 10 more minutes before I really have to go. So, we're gonna try and do this real quick. So when we so if I make B, this is gonna cry for a whole lot of reasons. Set register V. What else have we got? That's okay. Signal handlers. Yes, okay. I think we need to pass in the signal handlers to this. So we'll pass in a ref of a hash map. And it'll be the signal handlers. A ref of a hash map, U8 box dyn signal handler. Okay, so now signal handlers dot get blah, blah, blah. Okay, so this is the kind of untangling I was talking about, right? Signal handlers dot get. Cool. I need to rename this to be the map of all signal handlers. VM step. Okay, so now we're missing an argument, and we're gonna do this the dumb way, which is self.signal handlers. Right, and this won't work because we're calling a method on a mutable reference to ourselves. This is a borrow checker error as well. Signal handler is more private. This should be a pub trait. That makes sense. Halt on type. Wait, did that just work? I thought that wouldn't work. What? What? This should be a VM. There's no way that that works. There's no way. What? That's so insane. That's so insane. And then VM has a new method which just returns default, so that's a bit of a dud. VM dot, and let's maybe just add a method here that's called like isHalt, which just takes a ref to self and gives back a bool, and we return self.vm.halt. Okay, we fixed it. We fixed it. Christmas is saved, everyone. Sorry, isHalt. That's it. That's all we need. That's all we need. That's really funny. That's so funny. I cannot believe it. I cannot believe it. So what if I pipe this in? That's okay. That's okay. Because our virtual machine just doesn't have enough memory. Let's put this. Let's just make it nice and big. Okay. That still didn't quite work. Define handler, VM step. Why did this break? Buffered reader end. Oh, that makes sense. There we go. Okay, So that runs and that still works. That's incredible. That's incredible. So now we're gonna hit another problem because I'm gonna make WASM and we're gonna get some errors. Oh boy, we're gonna get some errors because we're relying on a couple of things here. m.halt equals true. Okay, so set halt. Because this works on a machine. This all works on a machine. So I'm gonna do the silly thing here. I'm gonna do the very silly thing here and just make this a pub field for now. And now we have this extra layer of interaction, which is very funny. Okay, halt cm. Now again, annoyingly, I can't just use make. So what do I have to do? Make is aliased to bugger. This was not correct. This is downloading a bunch of garbage. Okay. So default self m. Oops. Now this we can do. self.vm.is halt m.vm vm.memory vm.memory okay. This is because my handlers define handler signal halt. Where does this come from? This needs to take a VM. This is good. This is good. These are just warnings. Okay. So now I should be able to go into here and just like run this and it's okay. That's good. That's good. Okay. So now let's go one step further and let's, like JavaScript memory callback, we're gonna say struct JS signal handler. And it's gonna be a JSSys function. And we're gonna impl signal handler for JS signal function. This is good. This is good. This is really cool. So function handle, this takes a mutable reference. It takes a VM, which is a mutable reference to a VM, and it takes an arg, which is a U16, and it returns a result. And again, we should probably have a better error type at some point. So all we do is, how do we on read, on write? Read, write, JS value, null. We need call. Can we do this? Sure, let's try it. Let's try it. Let's find out what happens when I do this. So, oh yeah, and we need self, of course. So self.handler.call2. We're gonna also make a new context. This is JS value null. Call to this JS value from VM and a JS value from arg. I don't know if this works. We're gonna find out. If this is okay, if this is okay, no, we just want to map error. Uh-oh. Uh-oh. And then this is it. This is all we do. This is all we need to do. So let's try this. And then we'll also say impl JS signal handler. Actually, can this just be... We can just do this, right? And then self.o, right? We can just use this syntax. This is even simpler. So now we can go where we say we have our machine. We're going to make a function. It's going to be a wasm bind gen pub function. Pub function bind handler. And it's going to take a function in as an argument. Where do I do this? Map memory function. Yeah, so we just take in JS sys function. We return nothing. We say self.m.define handler. Oh, we need the index as well. So we say ID handler. And that's it. That's what we do, right? Not quite. JS. Oops. Signal handler. Okay, we're getting closer. From is not implemented. Okay, from VM. So. Oh, but. Wasn't bind gen. No, I want Rust objects in JavaScript. Exporting a struct to JavaScript? Yeah. Huh. Now this is hard because we probably need to wasm bind gen the struct because we're parsing it out. So let's do this. Let's just do this because I want to see it work and I'm running out of time. Let's go wasm bind gen. Because I have to do this. Memory mapper, memory mapper. Memory is a memory mapper. See, this then it infects the whole code base. It infects the whole code base. Okay, I've got to hurry up. I've got to hurry up. Memory mapper. I don't know if this is doable. Wasm bind gen. Yep. Copy is not satisfied. The trait bound copy is not implemented for memory mapper. Okay, here's the thing. Here's the other thing that would be cool. Can I ignore a field? Wasm. Can I ignore a field? Can I do this? Can I say wasm bind gen ignore? Except I have to build for wasm. We get a bunch of errors. That doesn't exist. This is a request. Skip. Why is this not fully on the screen? Skip. Skip on Rust exports. There we go. Wasm bind gen skip. Except I have to build for wasm. JS value from is not implemented. I thought implementing this would work. JS value from VM, wasm bind gen. Wasm bind gen pass rust struct to JS callback. There's got to be a way to do it. Mutable struct JavaScript callback. What about this? Into JS error, run any function. JS value. Exported types. See, I thought this, yeah, I thought this did that. I thought we could do that. Can we just... Well, here's the other thing. Let's just not pass the VM for now, right? We're honing in. Handler, define handler. It's not implemented for function. The trait is not implemented for function, which is required by function signal handler. Unsatisfied trait bound. Huh. That's weird. The trait for A is not implemented for function. Oh, right, yeah, of course. JS, what'd I call it? JS signal handler. That feels better. Unused result that must be used. Warning, warning, error. Symbol is already defined. Ah, we've got a conflict. We've got a conflict. JS name. Okay, excellent, excellent. Now, if I come in here, build, run, that looks okay. So if I go into test.html, oh my god, I've really got to get moving after this. Where we set up our VM. This code is all disgusting. VM.define handler. We're going to define handler FO, and we're going to define it as a function that we're going to try this. We're going to try this. Oops, hold on. I have a error, of course. Not settings. Tools. Oh, here it is. What is going on here? Why are these both? There we go. Thank you. Thank you. Console. Define handler. Bind handler for some reason. Sure. Let's do it. So if I build this, VM.bind handler is not a function. That's because I didn't actually do the whole thing. Okay, build. That is probably okay. Step. Nope, it's blown up. Unknown op required. Hold on. Build, step. And it works. Okay, Whoa, what a journey to get there. We've just, finally, after a lot of work, a lot of refactoring. I hope to do more things than that today. I need to go have a quick shower and get to my singing lesson, but we can bind a system handler, in this case for hex F0, to a JavaScript function, in this case one that alerts out to the screen. I'm going to reset and do that again because it's really cool. Wow. Well, that was a journey. Let's swap over to my wonderful little thing here, and let's make a check because that was significant work. It was a big refactor. It's going to be so worth it. This is going to let us do so many cool things in the browser. This was good. Today was a good day. All right. Thank you very much, everyone who tuned in. I'm not going to I don't have many viewers, so I'm not going to throw them onto a raid right now, but it was a fun time. Thank you, everyone. Hopefully this is going somewhere good. I can feel it. I can taste it. I'm really happy with how the new UI is looking. And yeah, that's going to be it for now. Thanks to everyone who's been following along on YouTube. A couple of people I see are watching quite a lot of the videos and leaving really good comments. So if you're one of those people, keep up the good work. I love it. And it is very helpful. I'm sure there will be people with very helpful comments on this video because I may not have done this completely correctly, but it has been a fun journey nonetheless. All right, I'm Tom. This has been great, and I will catch you next time.